All right, this word problem puts together a variety of things we're seeing over the last week or two. It's a word problem. Some puppy weighs 2 pounds at birth and 3.5 pounds 2 months later. Okay, so the puppy's obviously gaining weight. If the weight of the puppy during the first 6 months is increasing at a rate proportional to its weight, then how much will the puppy weigh when it's 3 months old? Okay, so they're telling us that the puppy's weight change, so dWdt, is equal to some constant times the weight. Okay, so that sort of makes sense, right? And I think I may use p on this one, p for puppy's weight. So dp dt equals kp. Okay, um, good. That's a basic differential equation, and one of the exercises about writing differential equations when there's a direct proportional relationship, that's the way it shows up. dp dt equals kp. But they want to know how much this puppy's going to weigh after 3 months. Well, in order to know that, we have to know what is the basic percent of weight gain. We have to know what K is. It's like KP. Well, what is that? Well, they give us some information. We know the puppy weighs at birth, and we know it weighs 2 months later. So I can use those two time periods to figure out what K is. Then once I've figured out what K is, I can plug in the new time of 3 and solve the problem. Okay, so a bunch of steps. If that seems like a lot, well, just slow it back down. I have a differential situation. I want to figure out the particular solution based on this rate of change. Okay, and I'm going to have to calculate the rate of change given two pieces of data. So let's first write what we know for the differential equation. dp dt, and again, p is standing for puppy weight, equals some constant times the puppy's weight. Okay. All right, so let's separate the variables. So I'm going to get basically that 1 over p dp equals k dt. And I take the integral of both sides. Well, the antiderivative of 1 over p is the log of p, all right, equals um, kt plus c, all right? All right, so, and what do we know? Well, we're given that the puppy's weight at birth, so that's basically, we're given here of when time is 0, the puppy's weight is 2. Okay, so it's 0, 2. So I'll write that down. Given 0, comma 2. So let's plug that in. So that means the log of 2 equals k times 0 plus c. Okay, so that means that c equals the log of 2. All right. Okay, so we've got something there. So let's plug that into the equation. So uh, log of p equals kt plus log of 2. All right. Well, I want the equation to be p equals something. And so I have to take this expression here and raise that up as the exponent. So e to this power. And if I do it on the left, I got to do that on the right. So e to the log of p equals e to the kt plus ln2. Okay. Well, either log of p, we've seen this multiple times. To what power do you raise e to get e to the power of p? Well, it's p. So p equals, well, p equals e to the kt. Well, it's that, but there's an exponent here it's added, right? So it's like that's equal to e to the kt times e to the ln2. Remember, that's like, x squared times x cubed equals, x to the 2 plus 3. Or if you go back the other way, if you have two different exponents added together, that's the same as the power times the power with those two different exponents. Okay? So, and e to the log of 2 is just 2. So that says that p at any time t equals 2 times e to the kt. Okay? By the way, this is just a classic exponential model situation. That's the starting value. Okay, but we've just figured that out. So now we know what that value is. I got to figure out what k is, all right? So let me clear up some of this stuff over here. So we'll do a little more calculation. Okay. So now I know that P of t equals 2e to the kt, all right? And I also know that there's another given. I know that at time, what was it? Time uh, 2, puppy weighs 3.5 pounds, okay? So now I'm going to use that down here. So this it's a second given. Okay, so basically given here, given 2 comma 3.5, I can say that P of 2 equals 2e to the k times 2, and I know that equals 3.5. So 3.5 equals 2e to the k times 2. Divide both sides by 2, and I get 3.5 over 2 equals e, I'll write that as 2k. All right. So I want to solve for k. All right. Well, I'm getting closer. Well, k is up here in the exponent, and I need to get that down out of the balcony. So I'm going to take the log of both sides. So the log of 3.5 over 2 equals the log of e to the 2k. Okay, well, the log of e to the 2k is just 2k. So I know now that log of 3.5 over 2 equals 2k, right? So I want to divide both sides by 2. So probably the best way to do that is, right now I'm going to say it's log of 3.5 over 2. That whole thing divided by 2 equals k, all right? And I'm going to go ahead now on my calculator just to see what that is as a decimal, right? I'm not going to show that on the screen. That's too cumbersome. So the log of, hit the log button, hit parentheses, 3.5 divided by 2, close the parentheses, and I get that log is 5596. So basically k equals, 2k. 2k equals 5596.5596. So that k equals half of that. But I divide that by 2, I'm going to get 0.2798. Okay. So now I want, the basic equation is P of any time t is going to equal 2e to the kt, right? But now I know what k is. K is 0.2798 times t. And I want the weight at time 3. So P at 3 equals 2e to the 0.2798 times 3. Okay. Well, if I multiply 2798 times 3, I get 0.8394. So this equals 2e to the 0.8394. And you should go and do these calculations. Sort of check me out on this, okay? So what is that? So e to 0.8394. So I put in e, second e, raise that to the power of 0.8394, and I get a 2.31. This is 2 times 2.3150. We always go out to 4 decimal places. So then I multiply that by 2, and our puppy weighs 4.6299 pounds. And typically, we go out to 4 places, then we round. And if I round that up, I would get 4.630. So that would be my puppy's weight at 3 years. And so let's go back. That's a lot of steps. Let's just go back and think through what we did. So we've got some information. First of all, that we know the nature of the relationship. The rate of change of the puppy's weight, and P is the puppy's weight, is directly proportional to the puppy's weight. The bigger the puppy is, the more weight the puppy gains. A small puppy can't gain much weight. A fat puppy can gain more weight. Take the antiderivative of both sides, take the integral of both sides, the antiderivative, and I end up with this particular equation. P equals P equals 2 times e to the kt. Okay, that's a classic, that's a classic expression. 2 is the starting point of the puppy's weight. It grows continuously, proportionate to the weight at any given time. Okay, so and 2 is the starting weight. And then I want to figure out what is k. In order to figure out what k is, I have to plug in a value at time 2 to see how much growth there is and how much k I need to get that growth. And so I solve that equation, I find out what k is. Then once I find out what k is, I plug that in, and we found out was, you know, well, I had to get log of 3.5 divided by 2 equals 2k. Do all that calculation, and k is equal to 2.798. All right, we're going to do this one again in class. It's relatively complicated, a lot of calculations. This is a classic problem that'll show up on the exam, and it's worth 9 points.